So let's look at the example case that we're all going to deploy together. So how many have deployed something to Kubernetes before? Reasonable number, 5, 6. Well, you all are about to, so you can put that on your resume and then ask for a raise. So you're welcome. So we're going to do that. Let's talk a little bit about what we're going to deploy. So I tried to create an example that would be somewhat realistic. There's various aspects to this that I'll describe just for the sake of time that I had to kind of trim down. But hopefully this will seem somewhat realistic to you guys. What we're going to do is handle the pre-processing, training, export, and inference for a model that takes in GitHub issues and summarizes them to like a short title, okay, using a TensorFlow model. Does that basic premise make sense? So GitHub issue comes in. I want to summarize it to a particular like title. Yeah. Sorry, say it again. No. So everything, since we're deploying everything on containers, then you could utilize anything you want. So PyTorch or Cafe or whatever you want to use. Yeah. Other questions? It's just this example will be TensorFlow. All right. So let's run through this. So the first thing we're going to do is we're going to have a raw data set. Okay? Now this raw data set that we're going to utilize is in CSV format. Again, this is one of those areas for the tutorial. It's pretty easy to pull and get that data. But you could think of this equally well like maybe you make a query out of a database and pull in a bunch of records. It would work exactly the same way. You would just need to connect to the database and run the query. But here we're just going to work with this static CSV file. So we've got this static CSV file. That CSV file is going to include a bunch of GitHub issue content and then a corresponding title of that GitHub issue, which will serve as our training examples for issue to summarization. Then we're going to split that into training and test set. We're going to pre-process the training data and output a serialized representation of how we pre-processed it, so we can also utilize that later on in inferencing and other things, and then a pre-processed representation of that data. Here, obviously, you would want to use that test set. I've got other examples that I can point you to where you would implement something like quality control in this sort of pipeline and only export models when they're quality controlled and tested. If you're interested in that sort of thing, I can point you to it. But we're gonna focus next on the actual training process. So we're gonna train based on these preprocessors and the preprocessed data. Output a serialized representation of our model. So TensorFlow is gonna output this model. And then what we're going to do is, OK, we have our serialized model. It's trained. Now we actually need to somehow get that model, that serialized model, into some place that it can do scalable inferencing. And Pachyderm is great for doing like batch processing, like this sort of thing. But oftentimes, what people will do is tag on the end of it, kind of like a build or export pipeline that builds a model and then updates a model in some inferencing system. So we're going to build a package of files that will allow us to wrap up our model into a Docker image. We're going to export that to a Docker registry, which you can think of just like a repository of Docker images. And then from the registry, then we're going to launch inference servers to do our inferencing. This is kind of the breakdown of what we'll do. Like I say, this is even somewhat of a simplification in that, like in the beginning, this might be driven off of a Kafka queue, like was mentioned, or a database query or whatever it is. Also, like before this build and export, likely you'd want to use your test data to do some quality control on your model before you build and export it to the registry. But this is what we'll get through today. Questions about that? Yeah.
Does your exported artifact contain pre-processing transforms as well as the model itself?
Yeah, so the question was, does the exported model include the pre-processing elements in addition to the model itself? So these will be represented by like pickle files that I've kind of represented there. I haven't put them over in the training repo, but those will actually get transferred through to the build package that will build and export to the Docker registry. That way we can use them for inferencing. Yeah. Yep. Yeah, that's a great question. So the question was, what if you have to run this like 10,000 times a day? I'll kind of punt this a little bit till later on because I'll show what happens, like how it's triggered and all of that stuff in a bit. But to answer kind of generally right now, people run these sorts of pipelines like multiple, on a sub-second level. It really just depends on like what your bottlenecks are. Like in your training process, if you're running it that many times, you might be doing some sort of online training, which this would support as well. So if you're doing online training, you can integrate that into here. It really just depends on like, this will scale in terms of data parallelism. Like if you're training, doing batch pre-processing across like many files, but it doesn't necessarily do job parallelism. So if you're creating like back pressure in these 10,000 jobs, then you would have to potentially deal with that. But there's certain ways to do that. I can talk more in the break with you. Other questions? Yeah.
Pre-processing, right? Usually we'll do data normalization. We'll obviously when you do inference, this normalization logic we also have to apply. Will packaging all those things also into the Docker or it's
Yeah, great question. So his question was also related to the pre-processing. So you'll notice here that I'm outputting some pickle files for my pre-processing. Those represent my serialized preprocessors, like for normalization or whatever it is. There's a couple of ways that you could do that. His question was, would you put those just in the Docker container, or would they go somewhere else because you need them in inferencing? There's a couple of ways to do it. So the first way is like you put your serialized model and your preprocessors in some data store. Here it could be in the version data store that we'll talk about. And then you make a request to your inferencing server and you're able to tell it like via environmental variable or parameter or whatever, pull these preprocessors in this model when you boot up, right? The advantage of that is that your Docker images are smaller and they boot up quicker and all of that. Some people, though, as well, depending on the size of their model, will just wrap their model up in the container or in the image and then deploy it that way. So there's both. Yeah.
So those rectangular boxes you're running them on Docker, right? And what about Kubeflow? Where does Kubeflow fit in here?
Yeah, great question. So the question was like what the rectangles correspond to, and then how Kubeflow fits into all of this. So each of these cylinders represents a collection of version data that we're going to manage with Pachyderm. So that's managed with that piece. Each of the rectangle pieces in this green color, or whatever color that is, are run as Docker containers on Kubernetes. And then each of those inference servers are spun up with Seldon. But remember that kind of Pachyderm and Seldon fit higher up in the stack than Kubeflow. So what will happen is we'll deploy Kubeflow, and then Kubeflow will give us some nice definitions to be able to deploy Pachyderm and Seldon on top of it and manage all of those resources. Then once we have Pachyderm and Seldon up, then we'll just talk with Pachyderm and Seldon to do everything else. So Kubeflow kind of provides that uniform foundation and convenience. Yeah. Other questions? In this case, the wrapper that we'll use is Python specific, but this could be, Kubeflow also includes CRDs for various other things. I know some of those are Python based. I don't think all of them are at this point, but in general, you could do inferencing. You could have even your own custom inference server that you're launching in Kubernetes or something like that, if you have your own API server or something. Other questions? Yeah.
You always have to chain them that way, or you mix and match?
Great question. Yeah. So the question was if I always have to chain them in this particular order, if I can modify that. That's totally flexible. So as we'll see here in a second, similar to with Kubernetes where we say, hey, you run these things somewhere, I don't care where. How we'll interact with Pachyderm is saying, I want you to run this to process this data somewhere, I don't care where, and this to process this data. You chain all those pieces together, but the actual structure of your pipeline is totally up to you. So I could have everything from just a single stage processing a single file all the way to 50 stages or even 20 different pipelines processing different files in different orders and that sort of thing. I could add another stage of pre-processing or post-processing or add in my quality control, like I mentioned, all of that stuff. So that structure is up to you, along with how you schedule each of these pieces on specific resources. Other questions? Okay. You guys ready to actually do something? Sorry it's taken this long to get to this point. At this point, we're going to do all of the rest together, but each of you have your own cloud instance. If you haven't yet, you'll need one of these stickers. There's little stickers up here at the two front tables with IP addresses on them. Go ahead and grab one of those now if you haven't yet, because this is when we'll need them. And we're going to move from this presentation over here to the GitHub repo. So this is the GitHub repo that we're going to be working out of for the rest of the time. And as you'll notice through this repo, I've tried to lay things out to where you can kind of skip around and see different pieces of the flow. You'll also notice that at least I attempted to get all of the commands that we're going to run together into here, so you don't have to worry about like catching something real quick with a picture. You should be able to follow along, copy, paste, and kind of modify the various commands to your particular machine to make it work. So go ahead and get to this README if you haven't yet, and that's where you can follow along with me. All right. So, yeah, I'll get it to you here in just a second. So the first thing that we're going to do is log into our instances, and I should note that I created all of these instances for you guys because it's easier for the tutorial. Normally, you would run everything we're about to run from your local machine, and you could do that right now if you wanted to. I just wanted to avoid everybody trying to install all sorts of crap all at once. So that's the reason for this. Just disclaimer. OK, so I'm on a Mac, so that's what I'll be showing here. Again, if you're on a Windows machine, you'll likely need to use like PuTTY or Windows Subsystem Linux to SSH into this machine. But you'll SSH in. Let me grab my, should probably grab my IP. And so you'll do something like this, SSH packrat at your IP. So don't use the IP that I'm using here because you'll mess up my machine, although I have a backup. But use the one on your sticker. So put your IP there. So SSH packrat at there. And then it'll ask you for a password. So the password is password, like that, all one word, P-A-C-H, password. Let me zoom in a little bit more. And if you do that successfully, you should see something like this, where you log in and it gives you some info. Yours, I have a couple things here already just because I don't want to expose all of my passwords and secrets to you guys during the tutorial. Yours should be blank. You shouldn't see anything yet. But you should be able to say cube control get all and see something like this. So cube control or cube cuddle or cube CTL, depending on your preferences, is the CLI tool for Kubernetes. So what we're doing here is we're saying, hey, do I have anything running in Kubernetes? Here, we're connected to Kubernetes and we can see that it's running. We haven't deployed anything yet to Kubernetes. So yeah, question? Yeah, so you'll want to log in as Pachrat, P-A-C-H-R-A-T. Yep. And then the password is the one I showed up here. I can go back to it. All right. Are people able to log in? Mostly? Okay, cool. I should mention here in about 15 minutes, we're going to take a brief break. If you do have trouble logging in during that break, let me know and I'll help you out. But I think we've got most people on there. So here, we're connected to Kubernetes. So let's think about what's going on here. Imagine this is your local machine that you're working off of, and you've deployed Kubernetes to AWS or to Google Cloud or to on-prem or wherever, and you're connecting to that cluster using kube control from your local machine. So this is essentially what we're mimicking here. I'm on a machine, I'm connecting to a Kubernetes cluster. Questions about that? Yeah. So there's a single node Kubernetes cluster running on this instance, so that's what you'll be using. But yeah, it would be the same whether that was true or not, whether you were connecting to AWS or wherever. All right, perfect. So we are at this stage, I think, right? We've got a set of resources. We've got Kubernetes deployed on that set of resources, so we've got a Kubernetes cluster. But now, in order to enable what we're going to enable, we need to deploy Kubeflow. And so that's what we're going to do next. So we're going to deploy, oh, sorry, before that, let's go ahead and clone this repo over to the machine. So here you can copy this git clone and just run that. And that'll get all of our files over to that machine. So you should then see this O'Reilly AI Kubernetes tutorial and stuff inside there that looks like this. Okay. All right. So just go ahead and type cd and get back to your home directory. So you should be here, home Pachrat. And what we're going to do is we're going to use this tool called ksonnet to deploy Kubeflow on Kubernetes. So ksonnet is one option for deploying packaged things to Kubernetes. Others are Helm and other things. The Kubeflow team has chosen to use ksonnet, so we're going to do that. So there's also a binary installed on here called ks. And what we're going to do is use that. But first, we're going to remember there was a question before about how do I manage all of these different various things on top of my Kubernetes cluster? Maybe I want to partition them out. So we're going to create a namespace for our Kubeflow resources. And this way, whenever we want to see all of the things running in Kubeflow, we can just reference that namespace and see all of those things. So we're going to create an, oops. I'm going to go ahead and copy this. We're going to create a namespace Kubeflow. So I just define that as an environmental variable because we're using that later. And then I'm going to use kubecontrol to create that namespace. And what you'll see here is you'll get some feedback. OK, you've created this namespace on your Kubernetes cluster. And then we're going to create a KSonnet app called MyKubeflow. You could name it anything you want, but that's what we're going to name it here. And we're going to initialize that. So this is going to contain, this app is going to contain a bunch of things that we want to, that we're going to want to utilize. Okay? And when you initialize that, what you'll see is that that creates a directory, MyKubeflow, and it basically generates a bunch of config for you out of the bat that you don't have to generate otherwise for using KSonnet. Okay. Now we're going to go into that application. So you can cd into MyKubeflow or run cd app name. And you'll see that we're now here in that folder. And we have a bunch of things, a bunch of pre-generated directories. And now, just to save us some command line arguments later on, we're just going to go ahead and set the default namespace for this application to the one that we created before. That way we don't have to reference it over and over again if we don't want to. All right, questions yet? OK. All right, now let's actually deploy something before our break. So what you're going to want to do, we're going to pull a bunch of config files from GitHub to help us deploy these KSonnet packages. What's going to happen if you do that, if you follow the next commands without doing this next bit, is that you'll get rate limited, and then you'll be sad. So to avoid the sadness, go ahead and follow in this README. There's a link here to create a GitHub access token if you don't already have one. So you can follow that link, create your GitHub token, okay? Copy that token. It should look like just a hash of letters and numbers. And then run this on the machine, which just is export GitHub token and then replace your GitHub token with the one that you copied over from GitHub. Okay? I'm going to go ahead and do that. I have it, since I'm doing this in front of all of you, I've just created a little thing to do that for me so I don't have to share my GitHub token with all of you. But all that's doing is running this command with my token. Okay? Does that make sense to everyone? So go to GitHub, get that token, and then run this export GitHub token equals your token. All right. If you have trouble with that, again, let me know on the break, and I'll help you. What we're going to do now is add a registry of KSonnet packages. And we're going to add one from the Kubeflow repository. So let me actually, I'll clear this so everybody can see it. So that's just copying from over here in the GitHub repo, this first command. I'm going to add that registry. And then I'm going to install some things. So what I want to install is the Kubeflow core, which is going to have all of those nice definitions and stuff I was talking about for running distributed TF jobs and Jupyter Hub and all of that. It's going to have all of those definitions for me. And then I need to install the packages that we're going to use in addition to that, which are Selden and Pachyderm. So if you copy this over the core and you run that, it'll say, OK, I'm going to go and get those files. Hopefully, so it retrieved 33 files that will help us deploy the core of Kubeflow. And then we're going to do the same thing for Selden and Pachyderm. So you can just copy those over. Say it again? It's just sets of config files. So when we deploy things here in a second, it will take those config files and sub in the any parameters that we supply, and then supply those to Kubernetes to do our deploy. So this is the part, again, that Kubeflow includes. We don't have to generate these from scratch. If we were doing this from scratch, we'd have to go through and create like, tons of different YAML files to be able to deploy all of these things, which no one likes to do. So here we're just doing it the packaged way. I forget what I set. Did anyone generated mine before? What? No. He didn't check. Did it work? Yeah, I think you don't have to check that. Yeah, good question. Okay, and then the last thing I do will install the package for Pachyderm. Okay. So now we've got, let's step back. So what we've done is we have connected to Kubernetes. We've created a namespace for all of our Kubeflow stuff. And then we've pulled a bunch of package definitions from the Kubeflow registry for the core of Kubeflow, for Selden, and for Pachyderm. So far, we have made no changes to our cluster other than creating the namespace. Okay? So what we want to do next, this will be probably the last thing we do before the break, is just run this ksgenerate command. So what ksgenerate's going to do is it's going to take those package definitions plus any command line arguments that we provide and generate the specific manifests that we're going to deploy to Kubernetes for Kubeflow. If you want to think about it, this is just taking a general template and making it specific for our cluster. And then we're going to take that template that we've made and deploy it to Kubernetes with this ksapply. So ksapply, hopefully in a second. It's thinking. Hopefully I didn't lose connection. It should work. Oh, there we go. All right, so you can see that it's deploying like things like TF Hub and Jupyter Hub and Dashboard, Ambassador, a bunch of things that you don't really have to worry about too much for here. But you can see that in the core of Kubeflow, again, it includes a lot of things that we would be potentially interested in using and operators for those things. So now it's deployed all those custom definitions to Kubernetes. And if we wanted to now, we could, for example, deploy like a distributed TensorFlow job in one command. And that would be much easier. When you do that, you should be able to do something like this. If we look at what pods are running in Kubernetes, we can see that there's a bunch that are creating. So all of this stuff, Kubeflow stuff, is getting deployed to the server, or excuse me, the cluster. It'll all come up and running here in a second. Once it comes up and running, you should see all of those statuses say running. If you're confused about the terminology like pod, we've introduced this new thing called pod. For now, I mean, you can just think about those as running containers. What a pod actually is a collection of containers. So there might actually be multiple containers running in a pod. But like here, you can think about them essentially like the running containers or applications in your Kubernetes cluster. OK, so that will get up and running here in a second. But with that, let's go ahead and break. It's 10:30. I've been drinking coffee, and I'm sure you guys have too, so we probably need a break. Any last questions before the break? Yeah. Yeah, Airflow is not as, so it's not integrated, as far as I know, not integrated with Kubeflow yet, but it is, they do have an operators who run it on Kubernetes. So what you would have to do if you wanted to use that was you would have to manage Airflow outside of Kubeflow. Yeah. Also, you would have to figure out solutions around like the provenance and data versioning and kind of distributed data processing things that we'll talk about here in a second, which are additional logic that you would need on top of Airflow to do the things that we're talking about. Other questions? Yeah. Yeah, if you guys, so if you take your, the question was if you take your computer out in the break, will it be easy to restart this? So you can just exit out of these and you'll be able to log back in, and everything will still be running. Oops. So my connection's a little bit slow because in one of the other tutorials they're probably pulling down like 10 gigabyte VMs or something ridiculous. But but yeah, you'll be able to log back in.